A meniscus is the curved surface at the top of a column of liquid. It occurs because the molecules of water and glass are both polar and therefore have a slight electrostatic attraction to one another. This electrostatic attraction causes the water molecules to be pulled up slightly by the glass on the edges of the container, creating the convex shape. In order to read the proper amount of fluid in the measuring container, one must look at the bottom of the meniscus to attain the correct measure. A stock solution is a highly concentrated solution. The purpose of the stock solution is to have a high enough concentration to allow for less concentrated solutions to be made. This is an especially useful technique when making a buffer solution in an acid-base titration. These less concentrated solutions are known as dilutions. The dilution equation is C1V1 equals C2V2. C1 will always be the concentration of the stock solution, and V1 will always be the volume of the stock solution delivered. C2 will always be the final concentration of the dilution, and V2 will always be the final volume of the dilution, which includes both the stock solution volume and the water used to dilute the solution. You will always have C1 when making dilutions, and V1 will just be whatever is dispersed. Usually when performing a dilution, you are trying to make a certain concentration solution, in which case you will need to solve for V2 to be able to know how much water to dilute with. Before starting the experiment, we rinsed the equipment 3 times with distilled water to clean it, then 3 times with the stock solution to make sure no water will accidentally dilute our solution. Using the graduated pipette, we measure out 5.73 milliliters of the stock solution. Note that the solution should not be drawn into the bulb. We then transfer it from the pipette into the volumetric flask. Now we use the pipette to fill the flask to the 25 milliliter mark with distilled water, making sure the meniscus sits on the fill line. This gives us a final concentration of 4.58%. After the dilution just shown, we made 2 more dilutions, but we do not have footage for them. Here are all of the measurements and calculations. You may pause now if needed. After the experiment, we cleaned up our lab space by washing the glassware in the sink, wiping the counters off, and returning all of the equipment to their proper places. Any excess solutions were poured down the drain.